Have you ever wondered how the vast expanses of our blue planet, the oceans, play a pivotal role in climate regulation? Well, buckle in as we dive deep into this intricate relationship. Imagine the oceans as a colossal sponge, soaking up vast amounts of heat from the sun. This is due to their high heat capacity, which allows them to absorb and store substantial amounts of heat. This ability moderates temperature variations on Earth's surface, creating a more stable, livable climate. Now let's set sail and venture into the world of ocean currents, such as the Gulf Stream and the Antarctic Circumpolar Current. Acting like nature's conveyor belts, these currents transport heat and nutrients around the globe, influencing regional climate patterns and weather systems. But how does this heat get around? Ocean currents redistribute heat from the equator to the poles, and from the surface to deeper layers of the ocean. This process helps maintain a balance in temperatures across different latitudes, contributing to climate regulation. Water everywhere, and every drop plays its part. The oceans are key players in the water cycle, which includes evaporation, condensation, and precipitation. Evaporation from the oceans contributes to the formation of clouds and rainfall, impacting both regional and global precipitation patterns. Sailing ahead to the carbon cycle, the oceans absorb and store carbon dioxide from the atmosphere, acting as a crucial carbon sink. This process of oceanic carbon sequestration helps regulate atmospheric CO2 levels and contributes to climate stability. Scene script. But what happens when these processes are disrupted? Changes in oceanic circulation and temperature can have profound impacts on global climate systems, underscoring the crucial role of oceans in climate regulation. Climate change, however, poses a significant threat to our oceans. One such consequence is sea level rise, caused by thermal expansion and the melting of polar ice caps. Rising sea levels pose major risks for coastal communities, ecosystems, and infrastructure. Moreover, increased CO2 levels in the atmosphere lead to ocean acidification. As more CO2 is absorbed by seawater, pH levels drop, impacting marine ecosystems, including coral reefs and shellfish populations. In the complex dance between oceans and the atmosphere, feedback mechanisms such as El Niño Southern Oscillation events and the Atlantic Meridional Overturning Circulation come into play. These feedbacks can either amplify or mitigate the effects of climate change, adding another layer of complexity to our climate system. At the heart of all this, conservation and stewardship of our oceans are paramount. Protecting our oceans and supporting sustainable practices are steps we can take to mitigate climate change impacts. So, make the choice today to be a guardian of our blue planet. Because every effort counts in preserving the health and stability of our climate and the life that depends on it.